Hello everyone, and welcome to our Cent S exam preparation series. In this video, we will go through the first 10 mathematics questions step by step. I will explain each question clearly, show you how to solve it, and go over all the answer options so you can understand exactly why the correct answer works. Let's solve this CENTS exam preparation question carefully. Two friends are discussing divisibility rules. Alberto claims, a positive integer is divisible by 6 if and only if the sum of its digits is divisible by 6. Bruno says that this statement is false. To decide who is correct, we must find a counterexample, a number where the sum of the digits is divisible by 6, but the number itself is not divisible by 6. Before checking the options, recall the correct rule. A number is divisible by 6 if and only if it is divisible by 2 and it is divisible by 3. Now let's test each option. Option A, 3,333. First, calculate the sum of the digits. 3 plus 3 plus 3 plus 3 equals 12. 12 is divisible by 6. Now divide the number itself. 3,333 divided by 6 equals 555.5, which is not a whole number. So even though the digit sum is divisible by 6, the number is not divisible by 6. This directly contradicts Alberto's statement. So 3,333 is a counterexample. Option B, 6,666. Sum of digits, 6 plus 6 plus 6 plus 6 equals 24. 24 is divisible by 6. Now check the number. 6,666 divided by 6 equals 1,111, which is an integer. So this number is divisible by 6, and it does not disprove Alberto's rule. Option C, 5,505. Sum of digits, 5 plus 5 plus 0 plus 5 equals 15. 15 is not divisible by 6. Since the condition fails immediately, this option cannot be a counterexample. Option D, 7,777. Sum of digits, 7 plus 7 plus 7 plus 7 equals 28. 28 is not divisible by 6. Again, this option does not satisfy Alberto's condition and is not a counterexample. Option E, 4,400 for sum of digits. 4 plus 4 plus 0 plus 4 equals 12. 12 is divisible by 6. Now divide the number. 4,400. 4 divided by 6 equals 734, a whole number. So this number is divisible by 6, meaning Alberto's rule works here. Final conclusion. Only option A, 3,333, has a digit sum divisible by 6, while the number itself is not divisible by 6. Therefore, Bruno is correct, and the correct answer is option A. Let's solve this logarithms question step by step. We are given the number x equals log base 2 of 18, and we are asked to determine which statement about x is correct. Before checking the options, let's recall an important idea about logarithms. The value of log base 2 of a number tells us which power of 2 gives that number. Now let's compare 18 with nearby powers of 2. We know that. 2 to the power of 4 equals 16. 2 to the power of 5 equals 32. This means log base 2 of 16 equals 4. Log base 2 of 32 equals 5. Now notice that 18 lies between 16 and 32. So since 18 is greater than 16 but less than 32, log base 2 of 18 must be greater than 4 and less than 5. Now let's check each option. Option A, greater than 4 and less than 5. From our comparison with powers of 2, this statement is true, so this option is correct. Option B, less than 4. This would mean that 18 is less than 16, which is false. So this option is incorrect. Option C, equal to 9. This is clearly incorrect because 2 to the power of 9 equals 512, which is far larger than 18. Option D, greater than 5. This would mean that 18 is greater than 32, which it is not. So this option is incorrect. Option E, negative. A logarithm is negative only when the number is between 0 and 1. Since 18 is much greater than 1, this option is also incorrect. Final conclusion. Because 18 lies between 16 and 32, log base 2 of 18 lies between 4 and 5. The correct answer is option A. Let's solve this averages question carefully. A student has an average score of 24 out of 30 after 3 exams. After the 4th exam, the student scores 30 out of 30. We are asked to find the new average after all 4 exams. First, remember an important rule about averages. Average equals total score divided by number of exams. So, the first step is to find the total score after 3 exams. If the average after 3 exams is 24, then the total score is 3 multiplied by 24, which equals 72. Now add the score from the 4th exam. 72 plus 30 equals 102. This is the total score after 4 exams. Now calculate the new average. 102 divided by 4 equals 25.5. So the new average is 25.5 out of 30. Now let's check the options. Option A, 25.5 out of 30. This matches our calculation exactly, so this option is correct. Option B, data not enough. We are given all the necessary information, the average after 3 exams and the score of the 4th exam, so this option is incorrect. Option C, 26.5 out of 30. This value is too high and does not match the calculated average, so this option is incorrect. Option D, 27 out of 30. This would require a much higher total score than 102, so this option is incorrect. Option E, 25 out of 30. This is close, but still not equal to the correct average. So this option is also incorrect. Final conclusion. After scoring full marks on the 4th exam, the student's new average becomes 25.5 out of 30. The correct answer is option A. Let's solve this inequality involving logarithms. We are given the inequality. Log base 10 of x is greater than log base 10 of x minus 1. Our goal is to find all values of x that satisfy this inequality. First, remember 2 very important facts about logarithms. Fact 1. The logarithm with base 10 is an increasing function. This means that if one number is larger than another, then its logarithm is also larger. Fact 2. A logarithm is defined only for positive arguments. So both expressions inside the logarithms must be greater than 0. Let's apply these facts step by step. Step 1. Consider the domain. For log x to be defined, x must be greater than 0. For log of x minus 1 to be defined, x minus 1 must be greater than 0, which gives x greater than 1. So from the domain alone, we already know that x must be greater than 1. Step 2. Compare the logarithms. Since the logarithm is increasing, we can compare the arguments directly. The inequality log x greater than log open parenthesis x minus 1 close parenthesis is true exactly when x greater than x minus 1. This inequality is always true, but only within the domain, And from the domain, we already found that x must be greater than 1. Now let's check each option. Option A, 0 less than x less than 1. This does not work because log of x minus 1 is not defined when x is less than or equal to 1. So this option is incorrect. Option B, x greater than 0. This is not enough because when x is between 0 and 1, the expression log of x minus 1 is undefined, so this option is incorrect. Option C, every real value of x. This is false because logarithms are not defined for 0 or negative values, so this option is incorrect. Option D, x greater than or equal to 1. At x equals 1, we get log of 0, which is undefined, so this option is incorrect. Option E, x greater than 1. This satisfies the domain of both logarithms and the inequality itself, so this option is correct. Final conclusion. The inequality, log x greater than log, open parenthesis x minus 1. Close parenthesis is satisfied for all x greater than 1. The correct answer is option E. Let's solve this plane geometry question. We are asked, in the plane, what is the locus of points equidistant from two distinct points? First, recall what a locus is. A locus is the set of all points that satisfy a given condition. Here, the condition is that the distance from a point to two fixed, distinct points is the same. Now let's think geometrically. If we take two distinct points in the plane and connect them with a straight line, the points that are exactly the same distance from both of them lie on a very specific line. This line is called the perpendicular bisector of the segment joining the 2 points. It passes through the midpoint of the segment. It is perpendicular to the segment. Every point on this line is equidistant from the 2 fixed points, so the locus is a single straight line. Now let's check the options. Option A, 1 or 2 lines, depending on the position. For 2 distinct points, the perpendicular bisector is always 1 line, so this option is incorrect. Option B, a line. This exactly describes the perpendicular bisector, so this option is correct. Option C, an ellipse. An ellipse is the set of points where the sum of distances from 2 points is constant, not the difference or equality of distances, so this option is incorrect. Option D, an oval. This is not a standard geometric locus and does not apply here, so this option is incorrect. Option E, 2 perpendicular lines. Only 1 line satisfies the equidistance condition, so this option is incorrect. Final conclusion. The locus of points equidistant from 2 distinct points in the plane is the perpendicular bisector of the segment joining them. The correct answer is option B, a line. Let's solve this geometry problem involving a rhombus. The question says, in a rhombus, if one diagonal is equal to the side, what is the length of the other diagonal? First, recall some key properties of a rhombus. All sides are equal. The diagonals are perpendicular to each other. The diagonals bisect each other. Now let the side length of the rhombus be S. Suppose one diagonal has length S. Since the diagonals bisect each other, each half of this diagonal has length S over 2. Now look at one of the right triangles formed by the diagonals. In this right triangle, the hypotenuse is the side of the rhombus, which is AS. One leg is S over 2. The other leg is half of the unknown diagonal. Let the other diagonal have length D. Then half of it is D over 2. Using the Pythagorean theorem, S squared equals S over 2 squared plus D over 2 squared. That gives S squared equals S squared over 4 plus D squared over 4. Multiply everything by 4. 4S squared equals S squared plus D squared. So d squared equals 3s squared. Taking the square root, d equals s times square root of 3. So the other diagonal is square root of 3 times the side. Now let's check the options. Option A, square root of 3 times the side. This matches our calculation exactly, so this option is correct. Option B, equal to the side. This would only work in a square, not in this case. So this option is incorrect. Option C, independent of previous data, arbitrary. The diagonal length is fully determined by the given condition, so this option is incorrect. Option D, square root of 2 times the side. This corresponds to the diagonal of a square, not a rhombus here. So this option is incorrect. Option E, double the side. This is clearly too large and does not satisfy the geometry, so this option is incorrect. Final conclusion: if one diagonal of a rhombus is equal to the side, the other diagonal is square root of 3 times the side. The correct answer is option A. Let's solve this trigonometry question carefully. We are given that an angle A measures 3 radians, and we must determine which statement is correct. Step 1. Convert radians to degrees. To better understand the position of the angle, we can convert radians to degrees. 1 radian is approximately 57.3 degrees. So 3 radians is approximately 3 times 57.3, which equals about 171.9 degrees. This angle lies in the second quadrant of the unit circle. Step 2. Recall the signs of trigonometric functions in the second quadrant. In the second quadrant, sine is positive, cosine is negative, tangent is negative. This is very important for solving the question. Step 3. Check each option carefully. Option 1. Tangent of A is greater than 0. In the second quadrant, tangent is negative, so this statement is incorrect. Option 2. Cosine of A is less than 0. In the second quadrant, cosine is negative, so this statement is correct. Option 3. Sine of A equals 1/2. There is no reason to assume sine equals 1/2 just because the angle is 3 radians. Also, sine equals 1/2 only at specific angles like 30 degrees or 150 degrees, so this is incorrect. Option 4. Sine of A is less than tangent of A. In the second quadrant, sine is positive and tangent is negative. A positive number is always greater than a negative number, so sine cannot be less than tangent. This statement is incorrect. Option 5. Cosine of A equals 1/10. Cosine in the second quadrant is negative, not positive 1/10. So this is incorrect. Final conclusion. Since 3 radians places the angle in the second quadrant and cosine is negative in that quadrant, the correct answer is option B. Let's solve this rectangle question carefully. We are asked, a rectangle has an area of 90 square centimeters, and its sides are in the ratio 5:2. What is the perimeter? Step 1. Represent the sides. Since the side ratio is 5:2, let the sides be 5x and 2x, where x is a positive number. Step 2. Use the area to find x. The area of a rectangle is calculated by multiplying length by width, so 5x times 2x equals 10x squared. We are told the area is 90. 10x squared equals 90. Divide both sides by 10. X squared equals 9. Take the square root of both sides, x equals 3. Step 3. Find the actual side lengths. Length equals 5, x equals 5 times. 3 equals 15 centimeters. Width equals 2x equals 2 times 3 equals 6 centimeters. Step 4. Calculate the perimeter. Perimeter of a rectangle equals 2 times open parenthesis length plus width close parenthesis. perimeter equals 2 times open parenthesis, 15 plus 6, close parenthesis equals 2 times 21 equals 42 centimeters. Step 5, check all options. Option A, 42 centimeters. Correct. Option B, 38 centimeters. Too small. Option C, 14 over 5 centimeters. Way too small. Option D, 21 centimeters. Half the perimeter. Incorrect. Option E, 14 centimeters. Much too small. Final. Answer: the rectangle's perimeter is 42 centimeters. Correct answer: option A. Let's solve this algebra question carefully. We are asked, for a positive real number a, the expression, open parentheses, a minus 3 divided by a minus 2, close parentheses, raised to the power negative 1/2, equals which of the given options? Step 1. Apply the negative exponent rule. Remember that raising something to the power negative 1 flips the fraction. Let's simplify this expression step by step. We are given a to the power of negative 3 divided by a to the power of negative 2, all raised to the power of negative 1 over 2. Step 1. Simplify inside the parentheses. We have a to the power of minus 3 divided by a to the power of minus 2. When dividing powers with the same base, we subtract the exponents. So we calculate minus 3 minus minus 2. Minus 3 plus 2 equals minus 1. So this becomes a to the power of minus 1. Now the whole expression becomes a to the power of minus 1, all raised to the power of minus 1 over 2. Step 2. Apply the power rule. Now we use another important rule of exponents. When a power is raised to another power, we multiply the exponents. So we multiply minus 1 times minus 1 over 2. Negative times negative gives positive, so we get positive 1 over 2. That means the result becomes a to the power of 1 over 2. Step 3, interpret the result. A to the power of 1 over 2 means the square root of a. So the final simplified answer is a to the power of 1 over 2, or simply the square root of a. Step 4, check the options. Option A to the power of minus 1/2, does not match. Option B, a to the power of 1/2, correct. Option C, a too large. Option D, a to the power of 1/3. Cube root, not correct. Option E, a to the power of 2/3, incorrect. Final conclusion. The expression, a minus 3 over a minus 2 to the power of minus 1/2 simplifies to a to the power of 1/2, or the square root of a. Correct answer, option B. Let's solve this question on parabolas carefully. We are asked, in the Cartesian plane, only one of the following equations represents a parabola with its axis parallel to the x-axis. Step 1. Recall the properties of parabolas. A parabola can open either vertically or horizontally. If the equation is in the form y squared equals something in x, the parabola opens sideways, and its axis is parallel to the x-axis. If the equation is in the form x squared equals something in y, the parabola opens up or down, and its axis is parallel to the y-axis. Step 2. Check each option carefully. Option A, 2x squared. This is just a vertical parabola with axis parallel to the y-axis. Incorrect. Option B, y equals 3x minus 1. This is a straight line, not a parabola. Incorrect. Option C, x squared plus 2xy plus y squared minus x equals 1. This is a complicated expression, but it is not in the standard form of a sideways parabola. Incorrect. Option D, y squared equals x plus 2. This is of the form y squared equals something in x, so it is a sideways parabola. Its axis is parallel to the x-axis. Correct. Option E, x squared minus 2xy equals 1. This is not in the form y squared equals something in x. Incorrect. Final conclusion. The equation that represents a parabola with its axis parallel to the x-axis is option D, y squared equals x plus 2. Quick tip for students, remember, the axis of a parabola depends on which variable is squared. Y squared means it opens sideways. X squared means it opens vertically. This helps you quickly identify the correct answer in the exam. And that brings us to the end of our mathematics questions. I hope these step-by-step explanations helped you understand the concepts clearly and made the solutions easier to follow. If you found this video helpful, don't forget to like, share, and subscribe for more mathematics and physics problem explanations. Thank you so much for watching, and I'll see you in the next video.